body is coming like this. This strikes a floor or a heavy body, heavy surface, table or so that this is almost infinite mass body, so this is not going to move. This comes over here, strikes it with the velocity u, rebounds with the velocity v, and with the normal, this is making alpha and this is making angle beta. That is, the velocity after the collision is making angle beta with the normal, whereas initial velocity is making an angle alpha with the normal. We are interested, suppose this data is given, we are interested what is the value of E. So we use the same thing. So E is equal to minus velocity of separation. Suppose we take this as object number 1 and this we take as object number 2, right? So E is equal to what object number 1 we have taken? We have taken this, 2 we have taken this, right? So what we do is, because 2 will always stationary, so it means whether we talk about V2 cos this thing or this one, U2 cos beta, these will be always be 0. So it is something going to be 0 minus V1. That is, what is this formula is going to take option over here. This will be 0 minus, this is velocity after the collision has taken place. What we do is, this way if we are taking the velocity as positive, so obviously this way is going to be negative. So this velocity, that is after the collision, this way is V, so this way is V cos beta. So we call it as V cos beta. U2 cos beta, once again this object is massive body, remains stationary. What is this? This velocity is in this direction. This is alpha. When this is in this direction, see this is in this direction. The component along the normal is in this direction, positive x-axis, if we are taking this as positive. And this velocity is in this direction. So along the common normal, it is in this direction is negative. So it is going to be minus u cos alpha. Minus minus plus, minus minus plus. So E comes out to be V cos beta upon u cos alpha. So E into u cos alpha comes out to be V cos beta. Once again, another important result. Now, if we say this body, in this body, when the body is going to collide like this, instead of making some angle, we say that this comes like this and goes like this. Let's say that is the case. So in that case, alpha is equal to 0 and so beta is also going to be equal to 0. When the body is coming like this and recoiling like this, going back like this, then certainly alpha is equal to beta is equal to 0 only. If alpha is equal to beta is equal to 0, cos alpha is equal to 0, we know. Beta we put equal to 0, then cos beta is also equal to 0. So from here we get EU is equal to V or V is equal to EU. Another important result. Over here, please do not take it as final velocity and initial velocity. That is generally what we have done in equation of kinematics when we have used it. Over here, the velocities V and U are the velocities just before the collision and just after the collision. Let's say a body has been dropped from some height onto the floor. This strikes the floor and rebounds to a height h2. Initially it has been dropped from a height h1, right? It falls on this massive earth or massive body, falls, rebounds to a height h2, and our intention is to derive this formula E is equal to h2 by h1. This is another important formula. So E is equal to h2 by h1, we have to derive it, right? Let's say how we get it. When this has been dropped from here, it means U is equal to 0. And over here, let's say coming from A to B position, let's say if we use equation of kinematics and we say V square minus U square is equal to AS. V over here is, we don't know, minus U square, it has been dropped, is equal to A is G, this is H1. So V is equal to under root 2G H1. Let's say it goes back. So this is what, this is the velocity of equation of kinematics we have used. So this is the velocity just before striking the ground. That is, if we talk about the this collisions, and if we talk about V is equal to EU, etc. So the velocity before collision is what we call it as U. Please do not confuse this V with this V over here. One is we are using equation of kinematics. The other is when we say V is equal to EU, V is the velocity just after collision and U is the velocity just before collision. So in equation of kinematics, what means from A to B, what is V is actually the velocity just before the collision, so this is going to be u, that is velocity before the collision, and it is under root 2gh1, right? So this is 2gh1. Now let's say, now this part is over, so I remove this so that there is no confusion. Now let's say this goes back, this is lifted, rebounds with the velocity v. So from here, from B to C, that is B to C, we can use conservation of kinetic energy also, or in case you wish to use once again equation of kinematics. So v square minus u square 2s, over here final velocity is 0, minus over here, what is the velocity? We are calling it as v, right? That is velocity just after collision has taken place, is equal to 2 minus g into to which height it rises? It rises to height h2. So h2 comes out, so v comes out to be under root 2g h2, right? So this is the velocity, this is what v is now over here, that is what it velocity stands for. This is the velocity after collision is equal to 2g h2 only. We know velocity after collision, when the case is something like this, it goes over here, strikes and comes back, when alpha is equal to beta is equal to 0, we have just done, is equal to E times velocity before collisions, we have just done. Velocity after collision is what? Under root 2gh2 is equal to E. What is the velocity before collision? Under root 2gh1. So E is equal to under root h2 by h1, a very important result which you shall be using probably time and again. Over here, one thing to note is, suppose some velocity is given. We give it some velocity, so obviously it rise higher. So if we use this E is equal to h2 by h1, so E will always change. Whereas E depends upon the colliding bodies, material of the colliding body, properties of these colliding bodies. One thing to understand over here, E is equal to h2 by h1 is like density of a body is fixed, like viscosity of a liquid is there, it has some number, refractive index is some constant. Similarly, E for the colliding bodies, that is also fixed, right? It depends on the properties. So it cannot change if you give more velocity, less velocity, so that all the time if you give more velocity, this rises to a greater height, h2 is changed, so all the time between E, between this body and this body is changed. No, this formula is only when it has been dropped. So if you are using E is equal to h2 by h1, please understand that this body has been dropped. It has not been given any velocity, neither in downward direction, neither in upward direction, neither in any other direction. The body has been dropped, then only you can use E is equal to h2 by h1, and that too it has dropped and it has fallen on this surface vertically, that is, it has struck this surface normally only, so that alpha is equal to beta is equal to 0.